4.4 is all about least common multiple, all right? So LCM is actually what I'm going to be calling it most of the time, but it stands for least common multiple. Let me explain to you what an LCM is. An LCM stands for the smallest multiple that two or more numbers have in common. Okay, so let's think about multiples. If somebody has multiple children, do they just have one child?
No.
No, they have multiples. Let's say if someone had twins, how many would they have? Two. Let's say they had triplets. Three. Okay, so multiples means it's going to get bigger. If you add multiple kids to your family gets bigger, okay? So I want to help you decide and understand the difference between GCF. What does GCF stand for? Greatest common factor. Say this with me. Factors fit into numbers.
Factors fit into numbers.
So just remember, if you're looking for a factor of something, it's going to fit into that number. But then let's talk about multiples. Everyone say multiples get bigger.
Multiples get bigger.
So when you think of LCM, it's the least common multiple. So it's going to get bigger. I want you to say these things with me. Repeat after me. Number one.
Number one.
So here's what we're doing for this. When you're finding the LCM by listing factors, you're going to write the first multiple of a number. Always put itself as the first one. Okay, repeat after me. Number two.
Number two.
You're going to go at least 5 numbers in order to find a match. Number three.
Number three.
The first pair that you find, you're finished. You don't have to go any farther. Number four.
Number four.
If there are no matches, you have to go for 5 more numbers. And finally, number 5.
Number five.
When you notice that you have a match, you can stop. So we're going to use these 5 steps now to help us find the LCM of these 3 numbers. Our instructions have asked us to find the LCM, or the least common multiple, of the numbers by listing multiples. Okay, so let's look at number 7. Let's go and write down number 7. The first thing you're going to do is put the number itself. Okay, now we are going to list multiples of the number. So look at your notes for me. Number 1 says the first multiple of a number is always itself. What does number 2 tell us?
Go at least 5 to find a match.
Go at least 5 multiples to find a match, okay? So basically all we're doing is we're adding 7 to each number, okay? So what's 7 plus 7?
14.
14. What would the next multiple be after that?
21.
21. The next one?
28.
28. And the next one?
35.
35. If you look, our notes told us to go at least 5 numbers to try to find a match. So we just went 5 numbers. Let's go to number 3, okay? It says the first pair we find, then we'll be done. So right now, we're going to go ahead. We just focused on number 7. Now we're going to focus on our next number, number 8. Once again, we will start with the number 8. That's the first multiple of 8. And now we're going to keep going, and this time instead of adding 7, we're going to add what to each number?
8.
We'll add 8 to each number, okay? What would the next multiple be?
16.
16. Okay, so really we're just seeing an 8 goes into an 8 one time, an 8 goes into a 16 2 times, and 8 goes into what number 3 times?
24.
24. What's the next one?
32.
32. And the next one?
40.
Now, you might say, I don't know how to find that. All you're doing to each one, we just added 8 each and every single time. You're allowed to use your calculators to help you find these multiples. The next number we have to do is what number?
14.
The final number from our original problem is 14. So we don't really know our 14 times table super well, so once again, you can use your calculators. But I always start with the number itself. So in this case, that is the number 14. Isabel, what's my next one?
28.
28. Michael, next one.
42.
42. Katie, next one.
56.
56. Landon, last one.
70.
Okay, so now what you're going to do is we've got to check to see if we have any matches. A match means all of those numbers have the same number in it. Do you guys see any number there that all 3 of them have in common?
Yes.
No, there isn't, okay? So for number 3, it was telling us first we have to find a match, but if we can't find a match, then what do we have to do? We have to add 5 more. So let's go back to number 7. We're going to add 5 more to it. Jakari, add 7 to 35, and what do you get?
46.
42. Kyla? Next one, Emma?
56.
Alex? We're adding 7 more to 56. Okay, very good. 63. And what's the last one, guys? 70. As you're looking at all those numbers right now, can you guys see something that all 3 of those numbers have in common? Any multiples they all have in common? No. So we have to bump down to the number 8, and we're going to find 5 more multiples of 8. All right, who wants to do it for me? Landon, go for it.
48. 64. 72.
One more.
8.
Now as you guys look at this, do you see anything that all 3 of them have in common? Emma, what do you see?
56.
A 56, okay? So our notes tell us that as soon as you find that, you're allowed to stop, okay? So I'm going to go ahead and circle them because it has the number 56 in common. So step number 5 says, if you notice you have a match, then you get to stop. And that is officially your answer. So I want you to write down the LCM, the least common multiple, is 56. Now basically what that means is the numbers 7, 8, and 14, they all fit into this right here, okay? So remember, say this one more time, multiples get bigger.
Multiples get bigger.
So you always want, whatever your LCM is, it's going to at least be as big as this big number or bigger, okay? But if you think about it, a 7 cannot go into a 14. The number that all of them share, well, a 7 can, but an 8 cannot, sorry, okay? So because of that, I know that I can't go on. It's not a 14 that they all can fit into. And we kept going into it and working it out, and we did find out that the final number that all of those numbers can go into is a 56, okay? So that's how you find the least common multiple, by listing multiples. I'm going to teach you now how to do it a different way also. So go ahead and skip a line and write this down. All right, for these notes that you're writing down right now, this is still finding the LCM, but this time instead of finding it by listing the factors, we are going to be doing it by prime factorization. The first step that you're going to do, just like when we found the GCF, is to do upside down division. Next, you'll have to list all the factors. Then you're going to circle any sets that you see there. The sets is when there's 3 of the same number. So you'll circle it, and those 3 will become one number. Next up, if there's anything that there's only 2, where there's a pair, you will circle the pairs, and the 2 will become 1. Then for number 5, you'll bring down the leftovers from least to greatest. So one thing you're going to hear me say quite a bit, because LCM, it starts with an L, you want to remember the leftovers, okay? How many of you have ever been to a restaurant before and you got leftovers and you took them home? How many of you have ever gotten home and then been sad because you accidentally left the leftovers even though they put them into the box, okay? Don't forget for this one, do not forget the leftovers. Just like the next day when you really want to eat that yummy lunch and you don't have it, you'll be sad. If you forget your leftovers for LCM, you will also be sad because you will get the wrong answer, all right? Then finally, for number 6, you'll multiply together everything at the end to find the LCM. So we are going to go ahead and do an example that has to do with prime factorization and the least common multiple. Looking at the notes or the steps that I just told you about how to do prime factorization, what does step number 1 say to do? Look at your notes.
It says to upside down division.
Upside down division. So just like when we find the GCF, we're going to go ahead and find these answers for upside down division. Who would like to do the 14 for me? Isabel, go ahead. 2 and 7? Is 7 a prime number?
Yes.
Very good. So we're finished. Who would like to do 28? Katie.
Okay, so it's going to be 2 divided by 3 and
All right, 28 divided by 2 is 14. Is 14 a prime number? No. What prime number can you divide it by?
2.
Divide by 2, and what do you get?
You get 7, and that's your prime.
And that is a prime number, so I'm finished. Michael, do the next one for me. Number 46.
You divide it by 2,
Divide by 2.
and that will equal 23.
23.
23 is a prime number, so we're done.
23 is a prime number, so we are finished. All right. So now remember our notes. Number 1 was upside down division. Read to me what step number 2 told us to do.
List the factors.
List the factors. Once again, guys, this is no different than how we did our GCF. So we're going to go ahead and list the factors for each of the numbers. Remember, for prime factorization, you're only listing the prime numbers. So these numbers that are out here on the outside we'll list, but we don't list the ones that are over there on the inside. So once again, we'll list all of these on the outside, but not the ones right there on the inside. All right, so we've done steps number 1 and 2. What does step number 3 tell us to do?
Circle the sets.
Circle the sets. Anything that's a set is if there's 3 in common. What number has 3 in common, Jakari?
2.
The 2. So let's go ahead and circle all of those. And those 3 become one number. So when I circle it, then I'm going to bring that down. That becomes 1. Are there any other numbers there that you can see all of them share? No. So let's look at step number 4. The first one I had to do was circle the sets. The 3 become 1. What does step number 4 say?
Pairs.
Do you see anything there that's a pair? That means just 2 in common. What is it?
2.
The number,
2 and 7.
2 and 7.
not 2 and 7.
Oh.
7 and 7 is a pair. Okay? What happens to the 2?
Multiply.
What do your notes say? It says the 2 become 1. So even though there's only 2 there, the 2 become 1. Now, if you were just finding the GCF, then you'd be finished. The answer would be 14. However, you have to bring down the leftovers. Everyone say LCM leftovers.
LCM leftovers.
This poor little number 2, it's leftover, okay? And I want you to put them in order from least to greatest, so I'm going to stick that 2 right there in front. And this 23 is also a leftover. It tells me for step number 5 to bring down the leftovers from least to greatest, and then my final step, I have to multiply all of those numbers together to find the LCM. So go ahead and pull out your calculators, plug that in. What do you get, guys?
644.
Wow, thank you for your excitement. So here we go. You're going to always write down LCM equals 644, because sometimes I'm going to be asking you to find GCF, sometimes it'll be LCM. So always make sure you're telling me in your boxed answer what that means. So what that is telling us, of our 3 original numbers, a 14, 28, and a 46, if I was trying to find one multiple that they all fit into, the least multiple, the tiniest number that these 3 ones fit into, is 644. Wow. So just remember, multiples get bigger. So as we're trying to find our answer, the multiples should always be at least the same size as the biggest number or bigger for all 3 of the numbers to fit into it. Okay, so that's how you find the LCM using prime factorization. Our final instructions for today tell us to find the GCF and the LCM of the numbers using prime factorization. Tell me one more time, what does prime factorization mean?
Upside down division.
Upside down division. So we're going to start it right here. You can use a lot of the same information for greatest common factor and least common multiple. So each of them, if it says prime factorization, we'll start with upside down division. So what's the tiniest prime number that can go into a 90? A 2. What is 90 divided by 2? 45. Who can give me a prime number that can go into 45? Jakari. Okay, he says a 5. There is one tinier, but I'm going to show you, as long as it's prime, the order actually doesn't matter. How many times does 5 go into 45? 9 times. Is 9 a prime number? No. Divide by?
3.
And what do you get?
3.
Okay, so here's the only difference. Now when you're listing out the multiples, you have to put them in order from least to greatest, okay? So what's the tiniest prime number you just had?
2.
2. What's the next tiniest one?
3.
3. Okay, so normally we would have them in order. That 5 is a little out of order, but once again, it doesn't matter because at this point, you've just got to put them in order. What's the next number?
3.
3. And the final one? 5. So as long as when you list them in order, they're in order, that's totally fine. Whatever order you do this area up here in does not matter to me. 165. Who can think of a number that goes into 165?
5.
5, okay?
Can't you go 15?
15.
3 and 5.
Listen, you could do 3 or 5, and I don't care which one you do. But 15 you can't do only because 15 is not prime, and you can only divide by prime numbers for prime factorization, okay? We're going to do 5. Some of you wanted to do 3. You could do it either way. It does not matter to me, okay? For this example, 165 divided by 5, what's the answer? 33. Is 33 a prime number? No. What number can go into 33?
3.
A 3. How many times? 11. Is 11 a prime number? Yes, it is. So now I'm finished. Okay? So for those of you who put a 3 right here, your numbers are just in a different order. But at this point, we're all going to put our numbers in order from least to greatest. So how you did it up there does not matter. First one should be a 3, then 5, then 11. Let me show you just the example. If you had done 165 divided by 3, what would that answer be?
55.
55. What number can go into 55? A 5. How many times? 11. So do you notice there, I still got a 3 in both of them. I got a 5 in both of them, and 11 in both of them. Order doesn't matter as long as when you put it down here, you put it in the correct order. Does that make sense? So either way is fine. I don't care the order that you put it in right there. Okay, next step. What do I have to do, guys?
Circle the pairs.
Circle the pairs. What's the first pair you see?
3.
I see 3s. Do you see any other pairs?
5.
5. Do you see anything else?
No.
Okay, so for the GCF, we have to remember the 2 become 1. So bring down the 3 and bring down the 5. What's my GCF? 15. So once again, this is why I tell you I want you to put GCF equals 15. Do you guys remember how we talked about relatively prime? Is 15 a relatively prime number?
No.
No. What number does it have to be relatively prime? Has to be the number 1. Okay? All right. Am I finished? No. It says also to find the LCM. Now, for the LCM, you're going to still do things with prime factorization, but I'm not going to make you redo this whole part up here. Okay? Instead, all you're going to do is just rewrite the numbers over here in order from least to greatest. The steps are super similar for LCM, but do you guys remember the one difference between LCM and GCF? What is it? Everyone say LCM leftovers.
LCM leftovers.
For the LCM, you cannot forget to bring down the leftovers. For over here, the GCF, you can just think they don't ever give you your leftovers. For an LCM, they get the leftovers and you don't want to forget them. So first things first, the pairs. What pairs do you see?
3.
We still have the 3s and we still have the
5.
Once again, still same step. The 2 numbers become 1. However, I've got to bring down the leftovers. Let's try to put them in order. What's the tiniest leftover?
2.
Okay, so I'm going to bring a 2 down. What's the next tiniest leftover? Bring down a 3. And the last one. Now I want you to multiply those together to get your LCM. What'd you get?
990.
990. So remember, don't just box in that answer. Instead, I want you to write LCM is 990. Remember what I taught you, something you wrote in your notes at the very beginning. We said factors fit into numbers. Do you see this number 15? Does that fit into those 2 numbers? Yes or no?
No.
Yes, it does. Just remember that factors fit into numbers. What's the thing we learned about multiples? Multiples get
Bigger.
They get bigger. Look at this. Did that least common multiple get bigger?
Yeah.
Yeah, and here's why. Because you were trying to figure out a number that 165 and that 90 can go into. It's a multiple of those numbers. So coming up on Monday, you're going to have a quiz. You're going to have to know and be able to figure out the difference between finding GCF and LCM. Okay? So tonight you're going to have a homework assignment. It's these problems right here. There's just 9 homework problems for tonight.